Alright, lesson 2.2 is all about polynomial functions of higher degree. The graph of a polynomial function is continuous, which means it has no breaks, holes, or gaps. So if you're looking at a graph something like this, where there's no holes there, if it was one of those like piecewise functions where maybe I go to here and I have that closed circle and then I pick up with an open circle, go that way, that would not be considered continuous. Or sometimes we'll have ones that have like a real sharp turn or sharp part of the graph like that. That sharp turn, instead of it being smooth, makes it so this is also not continuous. When I'm looking at a function f of x equals x to some power, if that exponent up there is even, then the graph is going to touch the x-axis at the x-intercept. So it's going to hit it and come back up, or hit it and come back down, just like all of these. If it's an odd number, so like x cubed, x to the fifth, x to the ninth, like these are, then it's actually going through the x-axis when at the x-intercept. So if it's even, it's going to touch it. If it's odd number, it's going to cross it. And that's not an even or an odd function. That's just looking at that exponent up there, if that number itself is even or odd. Describe the transformation and sketch a graph. So on this first one, we're still sticking with that x to the fifth, but that negative out front means it's reflected over the x-axis. So reflected over x-axis. And do bear with me, I'm using this device and trying to graph, so these are not going to be the prettiest graphs, but something like that. For x to the fourth plus 1, that 1 is going to shift my graph up 1, so it's going to be up here. And there's my x to the fourth. And then x plus 1 to the fourth is just going to shift the graph left 1. So this is all stuff we've done. Instead of my x-intercept being at 0, 0, it's over here at negative 1, 0. But you've seen this for a little bit, so this part isn't too new. It's from last chapter. You will still be looking at some of that stuff this chapter. So I just wanted to remind you about that. We can use that exponent to kind of decide, is it going to go through the x-axis, is it going to hit it and turn back around? Is the leading coefficient kind of lets us know if it's falling or rising or falling to the right. So as I go, we always go from left to right, whether my graph is going to end up by going up or if it's going to end up by going down. It does not matter whether it's an even or an odd exponent. So when n is odd, so if you are looking at an odd number and the number out front is positive, so this could be like 3x cubed, something like that, where the number out front is bigger than 0 and that number is odd. It's going to fall to the left, so it falls to the left and rises to the right. So because this number is bigger than 0, that's going to tell me greater than 0, lets me know rises to the right. And that's kind of how I'm going to remember that. If it's bigger than 0, it's going to rise to the right. The same thing is going to be true down here when n is even. It's going to rise to the right if a is greater than or equal to 0. So positive number here means I rise to the right. The difference is for odd functions, what you do to the left and the right is the opposite. So if I rise to the right, I fall to the left. Whereas over here, where n is even, if I rise to the right, I do the same thing to the left. They have to go to the same direction. So that's going to rises to the left. Now you might be thinking, oh, I bet the same is true for these negative ones. You're right, if this is negative, I'm going to fall to the right for both of these. Now it matters what the exponent is. An odd exponent means I do the opposite to the left. An even exponent means I do the same thing to the left. So that's my general what is happening. Now you don't get to just write it like that every day. Sorry, we're trying to change the color. That's not mathematical. So we do have to get our mathematical notation on here. Falling to the left. So the graph, f of x, is falling, which means it's going to go towards negative infinity, as to the left would be as x approaches negative infinity. So that's falling, and that's to the left. Rising means that my graph is going to go to positive infinity as x goes to, since I'm going to the right, that's positive infinity. So for all of these, we're going to have this same, excuse me, we're going to have this same format. Okay, so I went ahead and filled all those in. Now I just got to fill in the blank. For down here, rising to the left, so I'm rising, so I go to the left, rising, so again going to infinity, as I go to the right. And actually for all of these, I could go ahead and fill in my left and my right, my left and my right. If I rise, I go to infinity. I fall, I go to negative infinity. Fall is negative, fall is negative. Just like these were both fall, these are both going to the negative infinity. For all of them, you have x going to the left and x going to the right. So they should all have as x goes to negative infinity and as x goes to positive infinity. This is what we call our end behavior. And there are some practice problems here for you to do. So take a minute, pause this, and do those, and then restart it so you can see your answers. Okay, here are your answers. Make sure you've taken a minute and check those. Notice again, all of these have as x goes to the left and as x goes to the right. As x goes to the left, as x goes to the right. As x goes to the left, as x goes to the right. And then this is, what is my graph doing? Is it rising or falling? Polynomial function f of degree n, the graph of f has at most n real zeros. So if this was like x cubed, then that would be at most 3 real zeros. That means I could have no real zeros. I could have 1, I might have 2, okay, but I could not have more than 3. The function f has at most n minus 1 relative extrema, minimums or maximums. So if you think of like x squared, it's like this, and it has 1 extreme. So that would be 1 less than the exponent. So whatever your exponent is, that tells you the maximum number of zeros, and 1 less than that would be your maximum number of either of your extrema, so either your minimums or your maximums. Find all real zeros of the polynomial function. So with these, to find real zeros, you're setting it equal to 0. Up here, this is a cubic, but I notice there's an x in all 3 terms, so I'm going to factor that to make that x times x squared minus x minus 2 equals 0. Then I'm setting each of those, well, so then I can factor that middle part, and then I can set each of those equal to 0. So x squared minus x minus 2 is going to factor x minus 2 and x plus 1. When I set each of those equal to 0, I get x equals 0, x equals 2, and x equals negative 1. So those are going to be my real zeros. Down here, when I go to set this equal to 0, I can factor out that negative 2x squared, and I'm left with x squared minus 1 equals 0. The x squared minus 1 is a difference of 2 squared, so that factors to x plus 1 and x minus 1. And again, I have all these things multiplied equaling 0, so I can set each of those equal to 0. So this is going to give me x equals 0, x equals negative 1, and x equals positive 1. For that last part, I'm wanting you to find all of your relative extrema of g of x. I want you guys to do that, look at your calculator, and see if you can find them for right now. So I will let you guys do that since you can do that on your calculator, plus I'm kind of out of space down here. Be sure to let me know tomorrow if you have any questions on that. Okay, last slide. Find the polynomial functions with the following zeros. If I go back a slide, these zeros, the negative 1, the 1, came from having the opposite of that. So negative 1 came from an x plus 1. 1 came from an x minus 1. I'm using that to write my functions over here. So on this first one, x minus 2 is really going to be x plus 2 that came from. This comes from x plus 1. This comes from x minus 1. And this comes from x minus 2. Then I would want to multiply those out to actually get my function. When I do that, I'm going to group these a little bit differently so that I can do x plus 2 and x minus 2, and then x plus 1 and x minus 1, just because I know that if I do my x plus 2 and my x minus 2, that's going to give me x squared minus 4, and this is going to give me x squared minus 1. Then I can FOIL that. I get x to the 4th minus x squared, and minus 4x squared would be minus 5x squared, and then plus 4. So that would be my polynomial function that has those 4 zeros. Take a minute, write your factors out first, and that's what these are called, factors. Sorry for this awful handwriting. Get your factors out and then actually multiply your factors to get your equation. So down here I'm going to have x plus a half, x minus 3, and x minus 3. The only thing is here, typically won't leave this as, as a fraction inside my factor. I would change that one to 2x plus 1, and then x minus 3, x minus 3. And then make sure you multiply that out. Down here, this is going to give me x minus 3, x minus 2 plus radical 11, and x minus 2 minus radical 11. These second and third one, I need to distribute that negative to make that x minus 2 minus radical 11, and x minus 2 plus radical 11. The x minus 3 doesn't need to change. So again, these are my factors, which I will ask you to list out some. You're multiplying them to get your function.